Hi, welcome to the next class of binary search. Okay, so today we are going to solve the problem binary search in forest. Let's see what the question says. There are n trees in a forest. The height of the trees is sorted in the array tree, where tree I denotes stored, sorry, not sorted, that is stored in the array tree, where tree of I denote height of ith tree in the forest. If ith tree cut at the height edge, then wood collected is tree of I minus h, provided tree of I minus h, tree of I is greater than h. That means you have some n number of trees of height this. Like first tree has height 2, then 3, then 6, then 2, then 4. And you have to collect wood 4. For that, what you can do? You can cut every tree by some amount so that you have to make all tree height is equals to h. For all tree, those tree has height greater than h, that you have to cut down to h. Okay, so what you have to give output, your output should be h, that every tree should be cut to which height. Okay, so let's say there are 2, 3, 6, 4, 5. There are 5 trees. Okay, and every tree is, let's say we cut every tree to height 5. So obviously this is 2, this we cannot cut, so we skip that, we skip this also, this is 6. So we can cut that to 5, and we will collect how much would tree of I minus h. The current height will be 5 and the current height is 6, and after if we convert it into 5, so we will get one amount of wood. For 2 we will not get any wood, for 4 also we will not get any wood. So we got how much wood? One amount of wood. But the question says we need 4 amount of wood. Okay, so if we cut down every tree to height 3, now this is 2, you don't need to do anything. This is 3, it is already in height 3. This is 6. If we cut down this to 3, we will get 3 amount of, that is 6 minus 3, 3 amount of wood. For 2 we don't need to do anything again. For 4 also we need one, we will get one amount of wood. So total wood we got 4, which is required, which is said in the question. So what should be the answer? Answer should be 3. The 3 is that height where we are cutting down the tree. Okay. So let's see. Okay, there is nothing more. Okay. So let's solve the question. Take this 2, 3, 6, 2, 4. 2, 3, 6, 2, 4. This is at the height of the tree. Okay, and let's say we have, we need to collect 4 wood. Okay, so your answer could be, possible answer can be from 0, that you cut down every tree to 0. There at that time you will get wood or sum of all these. Your answer could lie between 0 to 0 to, let's say highest number of this, let's say 6. You cut down every tree to 6. What will happen? You will not collect any wood, isn't it? Because 6 is the highest number, so every number is less than 6, less than equals to 6. So you will not collect any wood. So at this case you will collect highest number of wood. So it will give highest number of wood, and this will give you lowest or 0 amount of wood. Next, amount of food. Okay, so then let's proceed with that concept. We can apply some binary search in the search space. Our search space is 0 to maximum of the element. So that is left is 0 and right is maximum element. Okay. Now, while L is less than equals to R, now if we check, let's say we got first mid, that is obviously L plus R by 2. Now, what does this represent? Mid says currently cut down trees to height mid. We are currently cutting down our trees to height mid. So int wood collected, how much wood we collect? We can get that after cutting the tree, okay, at the height mid. It will, let's say, return us the how much wood we have collected. If wood is the wood we have collected is equals to k, that means this can be a possible answer, isn't it? Possible answer, or it is a sure answer? It will be a sure answer. Yeah. So our answer will be, we can return mid as our answer. Okay. Else if our collected wood is greater than k, which is we have collected more wood than needed. That means how much we will go close to 0, we will collect more number of wood. Okay. So we need some less wood. We don't want that much of wood. So what we will do? We will update our left. We will convert our 0 to, like, if mid is 3, then we will convert this to 4. So we have got too much of wood. We don't require that much. So we update our low to mid plus 1. So we are increasing our height so that we get less wood. And at the else case, right will be mid minus 1. Now, if at the end of while loop, that is binary search, we don't get any element that is giving you the wood collected equals to k, that means it is not possible. Return minus 1. So what is the complexity? First, obviously, you are doing binary search, dividing it by 2, so it is log n. Log n actually max element. So we can write it as h, and at each case we are calling this function cut. What it will do? It will visit the forest, that is all tree, and it will cut down every tree to meet at end. It will get the sum of collected wood. So it will require order of n complexity. So total complexity is in log h. Okay. So now let's go and implement this. So our int low is equals to 0, high equals to maximum element of the tree to 3 plus n. So we have got our low and high. While low is less than equals to high, or left and right we can say. Let's use left and right. Int mid equals to L plus R by 2. L plus R by 2 is equals to 0 plus 1 plus 2 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 plus 1 int wood collected equals to, if we cut the tree to height mid, if the wood collected is equals to k, then we can return our answer. That is, we have to collect each tree to height mid. Else, if wood is more than expected, in that case we have to update our low to mid plus 1. At the else case, when wood is less than the expected, then we can go towards 0. For that, we can reduce our right to mid minus 1. And at the last, if we don't get anything, then we can return minus 1. Now, we have to define the cut function, int cut, which will have a tree array and length of the array and the height we are required to cut down. So for int I equals to 0, I less than n, I plus plus. So we have to collect wood. Let's say initially we have 0 amount of wood. Okay. So if current tree, ith tree has height greater than h, then we will cut it down. So we will collect wood of tree I minus h. That much wood we will collect from ith tree. Now we can return our amount of wood, that amount of wood we have collected. So I think that's all. Let's compile and run. Okay, so this is giving us minus 1. So maximum element we are getting here in the right, we are dividing it by 2 and cutting down. Okay, I'm sorry, wood equals to, not wood plus equals to, we will keep adding the wood we are collecting, isn't it? So I think this will solve our problem and we are good to go. Let's submit this. Let's wait for some time. Okay, so that's all about the question. This is a good question, easy level question, but it's okay, it's a good question. So thank you. Let's end the class for today.